Good morning. I am Swaroopa, working as an assistant professor in Marri Laxman Reddy Institute of Technology and Management. Okay. Today, I am going to discuss about the topic of designing a learning system. See, first of all, what do you mean by the designing a learning system? To get a successful learning system, we should design a properly. Okay, to get the correct model or to design a particular successful learning system, we should follow some steps. Okay, according to the steps, we can design a system. Okay, there are several steps to follow the design a particular system. Here there are the 4 steps to designing a learning system. First one is choosing the training experience, and the second one is choosing the target function, and the third one is choosing a representation for the target function, and next one is choosing a learning algorithm for approximating the target function. Okay, these are the 4 steps to design a learning a system. These steps we should follow to model a learning system. Okay, first step we are going to see about the choosing a learning system. Choosing the training experience. See, in this choosing the training experience, there are the 3 attributes are there. Okay, there are 3 attributes for choosing a training experience. The first one is type of feedback, and the next one is a degree, and the third one is distribution of the examples. Okay, these are the 3 attributes for choosing the training experience for the model of the learning system. Okay, first one we'll see about the type of the feedback. In this type of the feedback, there are basically 2 types of a feedback. First one is direct feedback, and the next one is indirect feedback. Okay, what do you mean by direct feedback? Okay, basically, suppose if you see one example, suppose I am sitting in a car. Beside me, one trainer is going to sit in a car, and he will say about he was a trainer. He was training me to how to drive a car. Okay, he is telling about the what is a accelerator and what is a clutch and what is a brake and how to go, how to drive, how to move in the hilly roads, how to go in the traffic roads. He's explaining me each and everything to drive in a car. Okay, the trainer will give the entire information. He will give feedback simultaneously at a time. Okay, he is sitting beside me. He is sending the messages, or he is saying each and every feedback to me. Okay, instantly the feedback is given by me. That is nothing but the direct feedback. In the direct feedback is nothing but whatever the instant feedback is giving simultaneously is giving. We can take the example of the car driving. Okay, car driving, we can take the example for the direct feedback is nothing but the trainer will sit beside me, and he will instruct me how to drive a car, and he will say about how to move in a hilly roads and how to drive in the traffic roads, and he will say the each and everything. The feedback is done at a time. Means simultaneously he's giving the feedback is nothing but the direct feedback that we can take from the choosing a training experience. Okay, next one is indirect feedback. In indirect, what do you mean by indirect feedback is nothing but it was not done the simultaneously. Okay, it is not done but the simultaneously. Whereas in the direct feedback, at a time, whatever he want to say, he was giving the feedback at a time simultaneously. That is nothing but the direct feedback. Whereas in the indirect feedback, the feedback was not done simultaneously. You can take anything example that we can take the indirect feedback. Okay, the result will be coming after. Suppose if you are writing exam, okay, the result will not come at a time. It will take some time. That is nothing but the example that we can take from the indirect feedback. The result will be not given simultaneously. Okay, the result is not given, whereas the feedback is also not given the simultaneously is nothing but the indirect feedback. Whereas the direct feedback, the feedback was given simultaneously is nothing but the direct feedback. Okay, this is the one of the attribute that we are going to use for the training of experience. And the next one is degree. What do you mean by degree? To which learner will control the sequence of the training. Whatever the sequence of the training that we are giving, it will be controlled by this particular degree. Again, this degree, they are again divided into the 2 types. Okay, with the trainer's help and with the trainer's partial help. What do you mean by the trainer's help? See, for this also we can take the example for the car driving. Okay, car driving. I'm going for a. I'm going for the to learn the driving. The trainer will be sit beside me and he will instruct me how to drive and how to drive in the hilly roads and how to drive in the traffic. All each and everything he are giving the feedback at a time, that is simultaneously with the trainer's help only. I'm going to drive a car. Okay, uh, with trainer's partial help means that suppose that have learned from my friends or neighbors. Okay, at 80% have learned from the outside and the 20% the trainer is going to give me. That is nothing but the partial help. He is giving help only up to the some extent only, whereas in the trainer help he is giving the help with 100%. He is giving the help, whereas in the trainer's partial help he is giving up to the help up to the 20%. There's a difference between the with the trainer's help and without trainer's help. Without trainer's help means without trainer's help will be there, but there will be only up to some extent it will be there. Up to 80% it will be there, up to 20% is it will be there, and the remaining 80% I have done by me, means I have learned from my friends or neighbors. That's it. Okay, this see, for this also we can take the example for the car driving. Also we can take, by taking the real time example we can easily understand what is going on. And the next one, see, in the trainer's partial help, which means which is completely by our own only. Okay, completely we have learned by our own up to 10% or 20%. We are taking the help from the trainer. Okay, that is nothing but with trainer's partial help. And the next one is, next attribute is distributions of the examples. This is the another attribute for the training of the experience. Okay, distribution of the example is nothing but here in the distribution of examples which tells about the performance of the final system. Okay, whatever the final system, whatever the final model which appears, the entire performance we can see in the distribution of the examples. In again, this distribution of example is classified into three types. Okay, in the distribution of examples there will be a more possible outcomes will be there. Okay, possible outcomes will be multiple number of outcomes will be there, and here also multiple number of situations can be occurred, and here we can take the multiple number of examples also. And we can also learn by the distributed ranging of the example. These are the three attributes or for the distribution of the examples. First one is in which we can get the more possible outcomes, and the next one is multiple number of possible outcomes, and the multiple situations, and the multiple examples, and the multiple over distributed range of examples, means number of situations or number of multiple times of all combinations will be get in the distributions of example. See, these are the three attributes for the first one is in the first one is type of feedback, and the next one is degree, and the third one is distribution of the example. These are the three attributes that we can take from the choosing of the training experience. See, and the next to design a particular system, this is the another step that we are going to follow. The second step is choosing a target function. Okay, what do you mean by choosing of a target function? To determine exactly what type of a knowledge the model will learn and how it will used for the performance of a program. See, exactly we are determining what is the knowledge of that model. Okay, how do you determine the knowledge of the model? By the performance only. If the performance is well, we can determine the knowledge of the model. If the performance is good, then we can say that the model is very accurate one. Okay, if the performance is not well, then we can say that model is not accurate. See, for example, this choosing a target function, we can take the example for the checkers problem. Okay, checkers problem is nothing but it's a game that we play. In the checkers problem, this problem that we can take the example for the choosing the target function. See, in the checkers problem, what we will basically do, it travels only in forward direction, means it does not go backward, it just go for the forward direction, and only it moves one move per chance. Okay, it will only move one move per chance. Okay, one move it will be done, and the next one it moves only in a diagonal direction only. Okay, it will not go backward or not go it beside or this side. It will move forward and it will move to the diagonal direction. And the third one is jump over the opponent. If one opponent is there in front of it, it can jump over it. Okay, this how the checkers problem we will play. This we can take the example for the choosing a target function. See, while moving the diagonally, set of all possible moves is called as a legal moves. See, in the checkers problem, when we are moving diagonally, whatever the opponent will be there, we are moving diagonally. That is nothing but the legal moves. In this, according to this designing a learning system, we can take it as a target function. It will be P of B, and the board state will be a B, and the legal moves is nothing but a set of B. See here, board state is B is nothing but whether the board state is initial or intermediate or final state. We can determine this 3 steps. Okay, initial state or intermediate states or final state. Okay, this checkers problem is directly related to this particular example. Okay, and the next one is to represent a target function. First of all, why we are using this target function? To get the knowledge and to get the performance of a particular machine, we are using the target function. Okay, by using the target function only, we will get the performance of a machine and we will get the accurate result. See, for if these are the terms that we used in the target function. First one is if B is the final board state, then that is 1, then V of B is equals to 100. See, this target function is based upon based upon the game that is nothing but the checkers problem. In the checkers problem, if B is the final board state, then if we won that game, then we will get the V of B is equals to 100. Okay, then if we are going to lose that particular game, then we get the V of B is equals to minus 100. If the B is the final board state, then if we draw that particular game, then we will get the V of B is equals to 0. Okay, these are the 3 steps that we can follow in the implementation of the system. If the final board state, if we won the game, then we will get V of B is equals to 100. If we get the final board state, if we are going to lose that particular game, we are getting the minus value. If we draw that particular game, we are getting the 0 value. Okay, if B is not a final state, then we are taking the term as V of B is equals to V of B1. Okay, B1 is the best final state in this particular step. Okay, B1 is the best final state, and these are the steps that we are going to follow the implementation of the learning system. See, and the next one is choosing a representation for the target function. See, what the representation that we are using for the target function, that we know in this particular step. Okay, to choose a representation for a target function, we are following some representations in this particular target function. See, for any board state, if board state is whatever it may be, we are going to calculate the function is C. We are going to calculate the function C, whereas C as a linear combination of the following board features, that is C of B. Okay, we calculate the function C as a linear combination. We are going to take as a C as a linear combination for choosing the representation. See, for choosing a representation for the target function, these are the features that we are going to use in this particular target function. These are the totally 5 features are there for using the target function. For the first feature is x1. We are taking the total number of terms, that is x1, x2, x3, x4, x5, where x1 is the number of black pieces on the board. We are taking the one final board state. In the final board state, these are the terms that we are using: x1, x2, x3, x4, x5. What do you mean by x1 is nothing but number of black pieces of the board. And then what do you mean by x2? Number of red pieces on board. What do you mean by x3? Number of black kings on the board. What do you mean by x4? Number of red kings on the board. What do you mean by x5? Number of black pieces threatened by red. Number of black pieces threatened by red means black which can be beaten by red. What do you mean by this threatened by red? Means whatever blacks are there which can be beaten by the red. Okay, these are the 5 features that we are going to use for the representation of the target function. By using these features only, we are going further step. And then and the next another step also is that is x6. X6 is nothing but number of red pieces threatened by black. Okay, this is the slightly opposite to the x5. Here here we are using v of b is equals to, this is the representation of the linear function, where c is nothing but the linear combination. For the linear combination, we are using this particular representation, that is v cap of b is equals to w naught of w1 x1 plus w2 of x2 plus w3 x3 plus w4 x4 plus w5 x5 plus w6 x6. This is a representation that we are going to use for the linear combination. See here, what do you mean by w naught and w naught? What do you mean by w? What do you mean by w naught to w6? These are nothing but the numerical coefficients. Okay, this we can say as a numerical coefficients or weights of each and every feature. We can say as a numerical coefficient, or we can say as a weight of the feature, and this is the representation of the target function that we are using. And w naught is also called as a additive constant. W naught is also called as a additive constant. Okay, and the next step is nothing but choosing a learning algorithm for approximating the target function. Okay, this is the last step that we are using the designing of a learning system. That is nothing but choosing a learning algorithm for approximating the target function. See, to learn any target function, we need a training examples. Without training examples, we can't learn the training function. For every training function, there will be a certain number of examples. Okay, with that examples only, we are going to learn the training functions. See, here in this training examples, basically what we are doing for the particular board, describe a particular board state and training value. Okay, here we are using the ordered pair values. What are the ordered pair? That is v train and b comma v train of b. These are the two order pairs that we are using for the approximating the training function. Okay, this is one of the example representation that we are using here. Mainly we are using the some examples, some training examples that we are using for the training function. To get the training function, we are using the training of examples. In the training examples, we are going to take some ordered pairs. The order pair is nothing but b comma v train of b. V train is nothing but v training function of the training example of the b. The next one is example. In this example, there will be a black won the game, that is x2 is equal to 0, which means no red. vb of b is equals to plus 100. Here also we are using one representation, that is x1 is equal to 3, x2 is equal to 0, x3 1, x4 0, x5 0, x6 0. Okay, this is all the representation that we are using for the training function. And to implement this particular training function, we need again two steps here also. We require two steps for training function. What is the first step? Estimating the training values. See, estimating training values means in every step we need a successor. Okay, v train of b, that implies v successor represents a next step. See, each and every training b we consider as a successor only. Then only we can go for the next step. Here v cap is nothing but it represents the approximation. We are choosing the approximation value for the p function. Okay, v target function, we are using the approximation. First we justify the approximate function, then we will get the exact value. Just we are choosing the approximate function here. Here v train of b, that implies v successor of b, means this v successor which includes the v training of b function. And the next one is adjusting the weights. Here we are going to adjust the weights. There are some algorithm to find the weights of linear function. Here we are using the least mean square. Here the representation is nothing but error is equals to v train of b minus v cap of b power of 2. Okay, this is the representation for the target function that we are using. See, in this again 3 more steps are there. If error is equal to 0, no need to change weights. If error is equal to positive, each weight is increased in proportion. If error is negative, each weight is decreased in proportion. Okay, these are the 3 steps that we follow for the adjusting the weights. Okay, these are the 4 steps that we include for the designing the learning system. Thank you.